Okay, let's get started. Good afternoon, everyone. Thanks so much for coming to this session. My name is Ray. I'm a developer advocate for Google Cloud Platform. And there are quite a few things I do. One is I love to bring some of our technologies to the Java community. The other part of it is I love to help our products to be better, to be more usable for Java developers. I've been a Java developer for a very long time, and for that reason, I love to create new things. So one of the things that I help the team to start was something called Spring Cloud GCP. So if you ever use Google Cloud with Spring Boot, check out the project. It's really, really nice, a bunch of nice and easy to use starters. I also help build help the products out a little bit. Like, for example, we just recently announced the App Engine for Java 11, something I helped work on as well. And very happy to be here back in DevOps Belgium. If you have any questions about the session today, you can find me on Twitter @Satanism, or you can find a lot of the content on my site, which is satanism.me. Okay. And aside from technology, I love to travel. This is a photo that's very special to me. As you can see, I was in the middle of the desert. Long story short, it goes something like this. I was traveling as a backpacker for about 4 months, a while back, and I came upon this city in China where I couldn't find a cheap place to stay. And so I was trying to figure out where can I stay cheaply, and I asked around, and there's a stranger who told me, well, if you actually take a bus a couple hours out, you'll end up in a desert, the entrance, and then you can walk into the desert for 4 hours, and you can stay there for free. And I heard the word free as a backpacker. I asked, which bus do I take? How many people here hiked in the desert by yourself before? Anyone? There's always someone in the room. Hey, really? Not today. But walk on the beach? Walk on the beach? Yeah, but it's not the same. Just saying, it's completely different. Completely different. In the middle of the desert, you look ahead, there's nothing. You look back, there's nothing but sand. Like in this photo, there are all these sand dunes, up and down, up and down. When somebody tells you, you gotta go walk in one direction. So it was southwest direction for 4 hours. You don't look around, you don't turn left and turn right. You just go over anything that's in front of you. So you can see all these sand dunes. I was taking up and down these sand dunes, and the sand is really soft, so every step that you take, you kind of sink a little bit, and then you have to pull yourself out, and it was hot, it was dry, I was thirsty, I was so tired, and when I'm on vacation, what am I doing? This feels like writing a J2EE application back in the days, and I'm on vacation, what am I doing here? But however, the end was very beautiful. The end was really nice. I got to the oasis, and it's a nice photo, and beautiful sunset and sunrises. And I think, for me, it was really about, no matter what we do, we always want to get to this end. We want to get to the beautiful place. It could be production. It could be, having someone using your application, your services. But the road to that is never easy, right? It doesn't matter what technology that we use. We are always going to struggle a little bit. And I think my job is to, hopefully get some of my experiences so that you don't have to struggle as much. Or if I can helicopter drop you into the oasis so you can skip, all of these troubles. But it doesn't matter what technology that we adopt. There's always something new, and we're always going to be learning and struggle a little bit. And I presented about Kubernetes 4 years ago at DevOps. So this was the video. We also showed some Raspberry Pi cluster running the Kubernetes on it. It was really fun. I had a lot of fun doing it. And fast forward 4 years, what I'm seeing now is now we're getting a lot more adoption. How many people here in the room are using containers today? Containers? Wow, just about everyone. And then using Kubernetes? Adopting Kubernetes, yeah. So it's definitely a lot more than what I did 4 years ago, but I see this adoption even more and more. And for the past 6 months, I have also been helping our internal teams, some of the internal teams, adopting Spring Boot and Kubernetes as well for one specific project. And I certainly learned a lot from a production experience. And today I'm going to share some of those things with you. I knew a lot of it beforehand, but then it kind of just validates a lot of the issues that you're going to run into. So the first thing about Kubernetes, I think that at one of the unconferences I've been to, I asked a small group who are using Kubernetes. And I asked them, what do you like about Kubernetes, or what do you not like? And there's always a split. There's always a group that says, I don't want to use Kubernetes, it's too complicated. And there's another group that says, we love it. This is the best thing that we have seen so far. And between the two groups, there are some interesting characteristics. And the people who really enjoy it, first of all, they say they always test. And they don't start with Kubernetes. They don't start with containers. They just start with their app. So they do testing, and they design their app really, really well. Okay? So for example, how do you design your app that that can be run in about anywhere? Right? If you don't think about Kubernetes, if you don't think about containers, then the basics is probably just designing a 12-factor app. And this is very basic, and it has been around for a long time. How many people here heard about 12-factor app? Okay. How many people here implemented all 12 factors? Wow. Very few, right? 10? 10 factors? No? 5? 1. 1. Everyone should have their hand raised for 1, because if you actually go and read 12 factor, the very first factor, I think it's have a code base. So I'm a little scared that nobody has this right now. Everyone should have at least 1, right? But start with your app, because, a long time ago, we are deploying to machines, and then we deploy into VMs, and then it's like, okay, we got PaaS, we got Cloud Foundry, we got, all of these other things, Mesosphere. It doesn't really matter. The trend is going to shift over time. And then it's maybe Heroku and App Engine and whatever, and then we have Kubernetes now, and there are newer and newer ways of deploying your app. But at the end of the day, it's really just about your app. Your app has to be designed well first, hopefully stateless, and hopefully following some of these best practices. Then you can carry the app and the same concepts along with basically any new technology that comes along. And that group also really, really love to test. So they test everything locally before they even consider containers or deploy it to Kubernetes. If you are developing a microservices application, make sure you mock your services so you can do some local unit tests. And then if you want to do over-the-wire test, you can mock over the wire as well using wire mock. And even if you want to go even further, define some contracts. And if you're using Spring Boot, you can use something like Spring Cloud Contracts. So you can define contracts, and you can test against these contracts a lot easier. And at no time in this case where you build a container and test it, right? You can just test locally and can test remotely if you want to have a CI/CD pipeline. And then finally, if you actually need to depend on something that cannot be mocked, for example, a database, right? If we sometimes create a local database testing with a H2 database that's in memory, but then that's usually something different from the real database you're trying to use, like maybe MySQL and Postgres, then you should really just test against those databases that you're trying to use, because there are always these small differences between the databases and the language that they actually use, right? The SQL statements that you need to create. And so if you really need to test against something that you cannot easily install locally, you cannot start from a JVM, then in this case, I would say use something like test containers. How many people here heard about test containers before? Okay, so some people here. So it's really nice. You should be able to, in your unit testing with test containers, you should be able to define what container you want to start during the duration of that unit test, like a PostgreSQL database with a Postgres container. And then throughout that unit test, you will be able to connect to that database, do all of your setups and tear downs and all of that. And then at the end of the unit test, you destroy it. And now you can have repeatable tests. And that's really, really important. Okay? So that's the first thing I'm going to say is just, don't start with any other technology except for your app, and make sure you test it really, really well and you design it really, really well. And then once you have the app that's well designed and you have some functionality implemented, then maybe you can start thinking about containers. And for containers, there are quite a few things to think about. Number one is that in the past, a lot of people, I think, I usually just create the jar package or the war package, and I toss it over the fence and say, here you go, figure out how to deploy it. And then there's always somebody on the team that's able to write all the documents on how to set up a proper runtime environment so that it can be configured to run this particular package. Now with containers, we are able to have that power of writing this documentation not in a doc anymore. We can actually write like a Dockerfile to define this runtime environment so that this environment can run my application. And that's the Docker image. And then you can take this Docker image and you can run it everywhere else. But now, because you have all the control, now you have the responsibility as well. What goes into this runtime image, you have to be very careful. You need to know whether there are vulnerabilities. You need to know what versions of everything you need to use. If there are any newly detected vulnerabilities, you are also responsible to make sure that it's being updated. So there's a lot more responsibilities with these new powers that you get. But it's really, really convenient because now you can always have a reproducible environment. However, in this environment, one of the most important things I'm going to talk about first is the JDK. Because not every OpenJDK versions are the same. Some of them are container aware, and some of them are not. If you ever use containers for more than, like, say, a week or two in almost a production-like environment, you're probably going to see this error message that says OOMKilled in your application. And most likely, the first thing I'm going to ask is, what version of the OpenJDK are you using? And second question is, how much heap have you configured and how much memory have you configured? Why is this important? A lot of people still kind of miss this part. If you're using a container version that's not an OpenJDK version that is not container aware, if you don't set the max heap, it's going to infer the max heap for you. And if you say that in my container, or for this process, you can only use 256 megabytes of RAM, the OpenJDK version that's older will not see this limit. And what the limit it will see is the actual limit on your machine, which could easily be 32 gigabytes or something like that. And it's going to infer the max heap from there, which then will be significantly higher than what you set for your container limit. So for example, if I'm using something like AU141, this is one of the older versions of the JDK, all I'm going to do is to grape for the max heap. And in this case, I'm running my container with 2 CPUs and 256 megabytes of RAM. That's the highest I can go. If I exceed it, I'm going to see that OOMKill message. So if I grep for the max heap, that's automatically inferred. I get this number. You might be thinking, oh, that's maybe 27 megabytes. No, not really. It's 274, which is already much bigger than 256. But if I were to go to, I never know how to figure this out, so I have to find an easier way. So maybe I'll Google it. All right, so what is that? Oh, sorry. bytes in GB. And that is actually 27 gigabytes of heap that's being allocated. And that is significantly higher than what you have set. And we know garbage collectors and we know JVM is trying to, when you start your app and you run it for a while, it will most guarantee to try to use as much heap as possible before they garbage collect. And very quickly, you're going to see OOM. Similarly, one of the worst, even worse issue that a lot of people don't see is the threads. So in this case, I only have 2 CPUs. And if I were to see the max thread for this particular instance, so for example, I go here and see thread. In this case, this is the thread that the parallel GC is using. And even though I give it only 2 CPU, I'm actually seeing the cores on the actual machine because it's not up to date. The OpenJDK is not up to date. And so now I'm seeing 16 cores. And so I'm getting 13 of those cores as my parallel GC threads. And this is especially troublesome to troubleshoot if you do something like this. A lot of people do, when you create a thread pool, you create a bounded thread pool. And how big is that thread pool? How many threads can you have? What do you use? We use something like runtime get available processors or something like that, right? And this number will be also run. So if you only give it 2 CPUs and you're spinning up thread pools that's like 16 or 32 threads everywhere, now you have a lot more threads, many more threads than you can actually handle, then you might actually thrash the threads and your application will be even slower for that matter. On the newer version of the JDK, if I do AUAA 222, sorry, if I find that same thing, and let me just go ahead and grep for the max heap. In the newer version of the OpenJDK, of course, it's container aware, so it's able to infer from the C group the max memory that Docker is using assigned, and we can see now this is actually 132 megabytes, just about. Right? So it's a lot better too, and the thread is also accounted for properly. The CPU is accounted for properly. Now, if you actually need to figure out how much memory you actually really need to use, there are a few techniques, and that's really useful. The number one is the amount of memory that's being used, you have to remember, is the heap plus the native memory. So we have to figure out how much heap you need for the app, but then you also need to kind of figure out how much native memory is actually being used. And Cloud Foundry actually has a really nice calculator here called the build pack memory calculator. And what they have found is that if you have the app, if you know how many classes and how many threads that you have, then you can kind of calculate approximately how much memory natively will be used. Because every thread that you use by default, it has 1 megabyte of thread stack. So if you are using something like Tomcat or something that's not reactive in nature, then if it's thread-based, then you might end up with the max thread of 100. And if one thread stack is 1 megabyte, then you're looking at 100 megabytes just used natively just for the threads. And that is already significantly more than what you expect for a 256 megabyte limit, right? And then all the classes are loaded into the meta space, and you need to know how much that is, right? So by having some of these basic information, you should be able to infer how much memory that you actually need and how much can be used for your heap, okay? And then if you really, really need to figure out exactly how much you are using, there's another really nice another flag that's in the JVM now in the newer version. It's called native memory tracking. So what this will do is that you add it to your startup command line for Java for the JVM, and then you can start tracking the native memory usages. And then at the end of the successful exit, it can print out the statistics that you collected. Now remember, I only said successful exit. What that means is that if you get OOMKilled, it's not a successful exit, you don't get to see this information. So you may have to over-provision a little bit to truly understand what you can actually use. So if you actually run your app with this flag, then at the end of the run, when you exit successfully, then you're going to see the native memory tracking information. So you can see how much heap is being reserved and used. You can see how much how many is used for classes and code, compiler, and everything else. In threads, I think it's in threads as well. So here we see we have 11 threads, and it's using up quite a few memory. So this is one of the easiest way to kind of figure out exactly what is happening. And I personally had to use this method to figure out why some of my app runs in one environment but not the other. And I actually was able to find some issues in some other systems in terms of how memory is accounted for, for example. And without this type of tool, we're kind of like guessing in the dark, right? So this is really, really nice. And then another thing that you should be looking out for is that please don't write to the file system in a container. And you might be thinking, well, I'm using Spring Boot. I'm pretty okay, right? Everyone here, how many people here use Spring Boot? Just about everyone. So you're pretty okay. Without any additional configuration, I don't think you're writing to the file system. However, if you build your own container that uses Tomcat or some other application server, usually, if you install those things by yourself, you most likely will have a default installation that will definitely be writing logs to the file system. Okay? And the trouble with this is that in the container systems, usually you don't have a log rotator, so there's nothing that will clean out the logs for you. So if you have a long-running system that's been there running for a while, and if you're appending logs all the time, you'll eventually run out of space for the host. Or if you're really dependent on these logs, these containers may come and go, and it will take away all the logs with the container as well. So you can't use the logs for real troubleshooting anyways. So what you should be doing is to write these logs to the STD out to make sure that the centralized logger can pick it up, and then you can do your troubleshooting and analysis in a centralized logger instead. Okay. Now, once you figure out your application, the runtime, and the JVM that you're supposed to use, then we can talk about how to create that container image. I have a 1-hour talk just on how to write a proper Docker file that follows some of the best practices. Okay, and it's a 1-hour talk, and I think that's a lot of things to remember. And you want to create an image that's properly layered. You want to make sure that's somewhat secured, and so on and so forth. It's a lot of things. And today, I'm not going to go into any of that. I'm going to say is rather than writing a Docker file, a lot of times what we do, we say from OpenJDK, copy the jar, entry point, run java-jar the jar, right? And then we say we're done, production, let's go, right? It doesn't implement any of these issues, and it can be bad. And so today, I'm just going to say, forget about this, all of these details, and because we actually have a tool that we can use that implement many of these best practices. And today, I just say, just Jibe it, right? How many people here heard about Jibe before? Yeah, all right. So if you haven't not seen Jibe, it's absolutely wonderful. I'm using this in our internal project as well, and so that we don't have to really think about how to write that Dockerfile, right? So for example, here I have an application. This is a very, very simple application, hello application. And it takes in a little greeting message, whatever, and then I say hello back, and that's really it. If I want to containerize this application, rather than writing that Dockerfile and follow through all of the best practices to just learn how to write a Dockerfile, in this case, I can just add the plugin called Jibe. So here I'm going to say Jibe, like that. And it's a Maven plugin or a Gradle plugin. You can use either of them. And all you have to figure out is, where do I add this and what image do I need to write to? In this case, I'm going to produce the image under this tag. In fact, this will actually push directly to the registry, even if you don't have Docker installed locally. So this is really nice. So even without Docker installed locally, you're able to create this image with some of the best practices and just push directly to the registry. And this is great, especially if you're in a CI/CD pipeline where you don't want to configure the Docker daemon either. And then, of course, maybe by default, we use something called distrolist. That's the base image that we have. Distrolist is pretty nice. It uses one of the latest version of OpenJDKs, and there are two variations of it. One of them has a shell, the other one doesn't. And if your company, however, wants to use some pre-approved base images, then you can do a from, just like in a Dockerfile. So you can from, and then you can pull in one of the base images as well. So for example, let me go ahead and grab that AU 222. Yep. So I'm going to just use this one instead. I'm going to use the slim version. And I can just add it here. And now my application, my image will be built with my application and using the OpenJDK AU222 image. And what this will do also is to automatically understand the structure of your application. This is the code that you wrote. This is the dependencies that you have. These are the resources, the properties files that you created. And then it will automatically do the layering for you so that you have a layer that only has the dependency, and the code layer will be very small so that when you actually make a modification to the code, it only swap out the layer that has changed, right? So if you never change your dependency, you don't have to re-upload 50, 60 megabytes of dependencies. And then one of the most important thing, though, that you do have to take away is that the question is, what user does this container run your Java application as? Okay. For the longest time, as long as I've been in the technology industry, there was one rule I remember, which is don't run your app as root. Just don't do it. And even in containers, that's the same because the container is not a security boundary. So, however, all of these base images, if you don't do any extra configuration, you are definitely running as root. Okay? So you gotta be careful with this one because when you go into production, somebody is gonna ask you, like, what are you running this user as? You're like, oh, well, it's root. And then they're gonna ask you to change it. And once you change it, there may be cases where your application doesn't work anymore because you're trying to write to file systems that doesn't have the right permissions anymore, right? So for this case, I would say understand this upfront and early, and just don't run as root to begin with. And in our case, we can configure it here. In Dockerfile, you just say user and give it the user ID and the group ID. Here you can say run as the user. I'm going to say this is nobody and no group. And these two names are actually in the Dockerfile, in the base image. So that's how I can refer to them as well. So you need to understand what your base image actually supports, and then you can then use those names in the file like that. And once you have this, then you can go ahead and build this application. So for example, I'm going to do a Maven compile. You're going to compile this first, and then I can say Jibe build, right? And this should be hopefully over this internet. Okay, so we built it, and then it's trying to build the image and it's pushing out the layers to my container registry. In this case, I'm using a remote registry on GCR, the Google Container Registry. And there you go. Now we have a Docker container. It's really, really nice, really easy to use. And that's probably one of the best way, in my mind, to create a container today. If you are into something like build packs, there's CNCF build packs today that you can also use fairly easily. You can say something like pack your app, and you can pack it into a container, so you don't have to write that Docker file yourself either. Right? So just stay away from that, unless if you absolutely need to, you want to install something special, then you can do it that way. Okay? All right, so now we talk about your application. When we talk about containers, we know what OpenJDK version we need to use, and we make all of these decisions. And now we can finally talk about Kubernetes and how to do this local development and/or just deploying it into production. So the first thing is that it's always kind of nice to be able to run my stuff locally. It depends on organizations. Some organizations, they will set up a centralized Kubernetes cluster so that you can remotely connect to it, and then you can deploy whatever you want. In a Kubernetes cluster, you can carve out the cluster into multiple namespaces. So I've seen that done before, right? So you have a giant dev cluster, and you get a namespace, and I just have control over my own namespace. But if I want to do this locally, there are only a few options. How many people here use a Mac? I just want to see a show of hand. Wow, just more. Okay. Windows, okay, very good. And Linux. All right. And Linux users, you're in luck. Because all the container constructs is all based on Linux. And if you're using Mac or Windows, you're bound to run a VM. So in that case, you need to run Docker for desktop or Minikube. If you're using Linux, you don't actually need to run a VM. I talked to someone from my workshop yesterday or the day before, and the question was, Minikube or Docker on desktop was really slow. Like, what can I do? I'm like, what are you using? Linux. Then I show him this thing called K3s. So there are two things I would recommend you to check out. One is called K3s. What is that, and what does it do? Let me see here. It's probably in this window. Oh, let me reconnect. So I'm using a Mac, so I cannot show K3s on my Mac. So what I'm going to do is just SSH into my VM. That's somewhere on GCP. If it connects one day, in the next 30 seconds or so, or not. There we go. All right. Oh, wow. Okay, good. Whew. Wi-Fi. All right. So if you got Linux machine, this is really neat. We explored this for our internal project as well. So it's called K3s.io, and you can just if you trust this very secure way of installing things as root. And I have no Kubernetes installed on a Linux machine. What this will do is really nice. It actually it downloads all the binaries, and then it sets up systemd, which I never want to touch, and then it will install Kubernetes node and stuff. And now I have Kubernetes running on my application, on my machine. And the best thing about this is not running in the VM. So this is really nice for a Linux environment. So now I have kubectl, and I can say, kubectl get nodes. And now I have, now this time I do need to sudo. So sudo kubectl get nodes. And you can change that permission, just extra configuration. And now I have Kubernetes connected to my local K3s node. And it's really, really easy and simple to use. And there's no VM behind it either. If you don't want it anymore, so every time after my demo, I do this K3s install, and everything's gone. Okay. Now, if you are using a Mac or Windows or something, if you do have Docker running somewhere, the other thing that I do recommend, or you can try, and even on Linux machines, this is really cool. There's a little tool called Kind. When you search, you have to search for Kind Kubernetes or Kubernetes Kind. Otherwise, you don't see Kind anywhere in the search result that you're looking for. Okay, so Kind is really cool. So Kind stands for, I guess, Kubernetes in Docker. Okay. So what that means is that as long as you have a Docker daemon, you can use Kind to create a cluster. And what this will do is that in the Docker daemon, it's going to download the Kubernetes master node, set up the API server for you, and then bootstrap Kubernetes server and with a single node running, all within the Docker daemon. Okay, so and this will come up in the next 30 seconds to a minute as well. And this is another way to set up a really lightweight Kubernetes. And we actually do use this one in the project that I work on. And because it runs in the Docker environment. What people also use it for is CI/CD pipelines or testing. If you ever need to test anything in a fake cluster, a fake Kubernetes cluster, you can spin up a new Kind cluster in your Docker daemon. You can run through all of your tests, deploy anything that you want, and then stop it when you're done. So this is pretty neat. Now, I wonder why this is taking a while, but the internet here, who knows? All right, so now you have the local environment. Then if I were to go back to that app, now here's the hardest part of this whole thing. Now we have to deal with YAML files. Okay. Now in Kubernetes, of course, one of the best thing about it, in my mind, is actually the YAML files, or a really easy way to declare what it is that you want to run and how you want to run it. And with the declarative model, as opposed to, say, a bash script or a programmatic model, right? And so one of the first things that you need to do in this case, of course, is to create that YAML file so that you can then deploy to Kubernetes. Now, there are two ways to do it. There's the easy way, the wrong way, and then there's the right way and slightly harder. And the difference is very, very small. So in this case, I have created my image. So I'm going to grab that right now. So here's my image name. The bad way of doing it is, of course, you do something like kubectl create deployment. You give it a name like demo devox. And then the image is equal to that. You hit enter. It goes straight to Kubernetes, and you're running it. Now, of course, you don't want to do this in your production cluster, right? This is the worst way to go to production. What you really want to do in this case is you want to do a you want to do a -- dry run. So this will basically simulate this whole call, and it will simulate that payload. And then you do YAML, and this will get you the YAML files that you need to bootstrap to run this application. And to me, this is one of the easiest way to do it. There are other generators to do it, but I just don't like how the files ended up as and what's actually inside. This is, you can do this for any other images. The result will be very similar. And then, of course, you should be checking in this file, right? So you're going to make the directory called KAS or Kubernetes, doesn't matter. And then, of course, you want to pipe this file into that directory, deployment.yaml. And now it's saved somewhere. So now you can check this in, and now it's more reproducible. Similarly, you might want to create a service in a load balancer in Kubernetes, in which case you can also use the same trick. You can say kubectl create service, and the service name is called demo devox, I believe. And in this case, there are many different types of service. For example, if you create a load balancer, this will be accessible from outside the cluster. And in my case, I want to do cluster IP so that it's only accessible internally. And then you do dry run and YAML, right? I also need to tell it which port this service, this load balancer, need to listen on. So I say TCP 8080, 8080, something like that. And do the dry run. No, what is going on here? Equal? Oh, is there a dash before?
You're missing one.
Oh, of course. There you go. Nice. There we go. Very cool. So now we got this whole thing generated, and then I can go ahead and put it somewhere, service.yaml. Okay. And of course, I can now go ahead and deploy it. So for example, apply KAS, and this will then, I check it in. Maybe I have a CI/CD pipeline. It will do the same thing. It will apply it. And now I should have my application deployed in my cluster. Of course, you only do this after you successfully tested everything locally, and you really want to just try everything out now in your local environment, full end-to-end. And this is one easy way to do it. Now, once this is up and running, of course, we can see the logs. So just to be sure everything's running, I'm going to say kubectl logs, and just to see everything's there. And yeah, it got started properly. And then if I want to test it, because my service is a local cluster IP service, so if I say get SVC, my service, my load balancer into this application is local, only within the cluster. So I have a 10.x whatever IP addresses. In this case, I cannot access it. So how do I do that? If I want to try this out in my local machine, I would have to create a pull forward. So I can say kubectl pull forward to the service, not the IP address, to the service called demo devox, and I can bind the port, for example, my local port 8080 to the remote port 8080. Hopefully that works. So what this will do is to basically tunnel my local machine port into that pod, into that container. And now if I go and trigger this, so for example, open up a new console, I can say clone localhost 8080 and say hello, and name is called Ray, and this is ZSH, so I have to quote right there. And it actually produces the output, right? So now we can see the output from my application. Now, wait a second, though. I did see that I did missing a space here. So what do we do? Typically, in the what I've seen a lot of people do is that we will go back to the IDE. right? And we'll try to fix it. And then now we have to go in Maven and Jibe build again. We build that container. And then we have to go back to our cluster and find the pod that's running, like that one. And then we have to go ahead and kill it, because then once you repull, then it's going to get the latest version. And then you go back and start your pull forward again, and then you do this whole thing one more time. And that's a loop that will just keep on going. And a lot of these mundane tasks people do manually. So what we have created at Google is some tool. One of the tools is called Scaffold. Okay. So with Scaffold, what this can do is to help you to have basically automate that loop I just talked about, and so you don't have to do this manually. Okay. So for example, if I go back to this app, if I want to start this type of development loop, if I want to try everything out in the cluster, then what I can do is to create a scaffold file. So I'm going to create a new file called scaffold.yaml right here. Okay, and I think they do give you a little snippet here in the template, so we can say scaffold config. It looks very similar to the way that you might create a Docker Compose file, right? In Docker Compose, you have a single file that has multiple services that you want to start all together. In this case, you can have multiple artifacts and deployments that you put in here, so you can deploy many, many things at one time for a end-to-end full deployment. So for example, in this case, my image is called this. So I'm going to copy that. And then the builder is Jibe. So by default, if you just do this, it's going to infer that you're using a Docker file. But since we're not using a Docker file, we have to tell it what it is that we're doing that we want to use to build a container image. In this case, we're using Jibe, so we say we want to use Jibe. Okay. And then underneath here, we can have potentially arguments. So we can say something like args. And you can pass in additional arguments that you want to pass into the Maven build. So for example, this is what I do, but do not do this in your own. I love to do this one. Skip test. So something, so that my demo will work better, but you don't do this in your own. Okay. So anyways, and then you can tell it which files I want to deploy. In this case, I remember I outputted all the YAML files out. Then I can say all the files is in my KAS directory. And that's pretty much it. Okay, so I think this works. And then what I can do is go back to Scaffold, go back to my command line, and I can probably do Scaffold dev. And we'll see if I configure everything right. So in this case, what this will do then is to discover the scaffold.yaml, and it's going to go ahead and say, oh, I need to use Maven and Jibe. So it's going to go ahead and build this container image. And once it builds the image, it's going to deploy the files for me, and then watch for changes. Okay. So now if I want to fix this issue, I just go back, modify the code, I come back, and it's going to redo this whole loop for me, which can be very useful. Now, if I want to test everything out locally too, I see if it was local, then I can add pull forward, and this will automatically discover what services you want to deploy, and then establish the pull forwarding for you as well. Now, of course, I can also do this from the IDE. We do have a plugin called Cloud Code. And with Cloud Code, well, in IntelliJ, in VS Code, it will automatically discover the scaffold.yaml file. And then what this will do is to be able to give you this run button here. And I should be able to run my code, run this whole loop directly from the IDE. Now, let me give it a try, because I don't think there's one thing that didn't bootstrap properly. So I'm not 100% sure if this is going to work. But here we have a debug icon. So what this will do is not just run this development loop, but hopefully also started in a debugger mode. Okay, so what this is saying is that one of the profiles not found. Okay, that's no good. So let me delete one, and let me see if I can create another one. Cloud Code Kubernetes. Okay, so here we have the blah, 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 and let me give it a name, like DevOps, and apply, and okay. Now, usually this is automatic. Something didn't catch up. So anyways, so now this scaffold command line is slightly different. So it's doing scaffold debug with the files. And then somewhere along the way, there's a pull forward. And what this will do is to actually establish, it will modify the entry point so that it starts up as a debugging mode, and then establish the pull forward so that from the IDE, I have a debugger that's now attached to that process that's running in Kubernetes. And now if everything works, I should be able to go and say, let me go ahead and write this and put a breakpoint here. And if I kind of figure out which port this is listening on, so let me find it. Yeah. So along the way, it says, here we go. So my local port 8080 is now the remote port 8080. So I should be able to go and say localhost 8080. Hello, name is equal to DevOps, for example. There we go. And if the debugger actually took hold, which it didn't for whatever reason, it should stop the process and we should be able to debug it. But I don't know why that didn't do it. But however, let me see if this actually works. So if I changed out the name here with a space and save. Now, hopefully, if there's something obviously not working properly today, but usually when this is running, if I save this file, then this will kick off the process again and restart my app and do the whole redeployment again. So I'm going to stop using this one, and I'm going to go back to my command line and just do a scaffold dev. And this one I'm sure is definitely working properly. Okay. So far so good. All right. So this is how we can iterate. Now, however, there are a few things I do want you to watch out for with the last 10 minutes or so. Number one is in these files, there are a few configurations that you do really need to pay attention to. One of them is the resource. Okay. Why is this important? Resource has two parts. There's request and limit. Request is how much you need minimally. So for example, I need at least 256 megabytes of RAM. And I need at least 4 CPUs, so I'm going to say, or 2 CPUs, I'm going to say 2000 M. Now be careful here. The small m and the big M has very different meanings. Small m means millis, so it's 2000 divided by 1000. Whereas the big M means 1000, so this is 256 megabytes. Do not do this. I have done this myself, which I give my memory 256 millis, and my app never started. So don't do that. So just remember that. And of course, it's megabytes and megabytes, small differences. And then the most important one is the limit. Then you can give the limit of, 512 and the CPU of 4000. Now, the limit is what restricts you from going overboard. And so imagine if you did not set a limit and one of your instances got DDoSed, then it's going to potentially use up all of the CPUs and all of the memories. Then you're starving other applications from being able to use it. And in this case, for the limit, then I'm saying this is the max that you can use. Now, also very importantly, is remember that OpenJDK thing with the container awareness? If you didn't set max heap, it's going to infer max heap from something else. If you didn't set the limit, even if you're running a container-aware JDK, if you didn't set a limit, it might still see the host memory as the limit, and you're still going to be using up more memory than you wanted them to use, okay? And then you potentially will starve every one of the JVMs on that machine. So very careful. So this is the first thing. Always set the resource, especially the limit. You can also set the default one in the namespace. So if you don't want to do this for every single workload, you can set something that's default. So whenever you deploy into that namespace, you get a default resource request and limit. The second really, really important thing is the health checks. Okay, so there are two checks in Kubernetes. There's the liveness probe, and then there's the readiness probe. Okay, and these two probes are very important. The liveness probe tells Kubernetes how do I detect that you're alive, and if you're not, I can recover it by simply restarting your instance. Readiness probe says, when can I enlist your application into my load balancer so that I can start serve traffic with your application instance? Okay, those two things mean very different things. For example, your application could be live but not ready. Why? Because you're trying to pre-warm the cache or load some more data before you serve any traffic. However, you got to be very careful because in Spring, we know we have Spring Actuator. And the actuator has a health check. Which one of these two do you put actuator as the health check? Okay. Now, the thinking process is like this. Can my app recover if the health check fails? Okay. What does that mean? If my health check is dependent on an external dependency, something like another database. If my database down, can I recover my application by restarting my application? No. right? Because the database is down, there's nothing I can do about it. If you start my application, I'll just come back and still not going to be connecting, right? So that's the thinking process I go through now, right? So for example, if you actually have your health check the liveness probe depending on the database, what's going to happen is this. Your database goes down, your app fails the liveness check, and then Kubernetes kills it, restarts it, and now it kills and restarts every single one of these apps. And now other people, depending on your service, will say, oh, wait on a second, your app is down. And then that application that depends on you is going to get killed too, right? So now you have a cascading failure. So be careful, don't do that. So I would recommend for the liveness check, do a very simple check, just return OK on a HTTP handler that runs in the same thread pool that you are using to serve. Because sometimes you might be using different thread pools for different endpoints. Just make sure you use the one that you're using to serve. And then for the readiness probe, you can potentially use the health check, the actuator, but also be careful. Because not only does the readiness probe tell Kubernetes when to enlist your application into the load balancer, if you fail it, it's going to also take it away from the load balancer. And this is how you actually do graceful shutdown in Kubernetes. Okay? And it's a very tricky way of doing things. So, for example, when Kubernetes wants to shut your application down, it's going to send you a signal. It's usually a SIG term, and you are supposed to catch it and then do a graceful shutdown. Okay. And you might be saying, OK, I'll just shut my application down and don't care about any more incoming requests. You can do that. However, your app will still be enlisted in the load balancer, in the service, and there will be still requests that's trying to reach your particular instance that's being shut down. So there are very few right way to do it, and I'm going to break it down a little bit for you. Okay, so this is the anatomy of a graceful shutdown for something that's running in Kubernetes, and this is something you do have to take care of specifically for Kubernetes. First, you're going to receive the SIG term. We're telling you I need to shut you down, and then what you're supposed to do is to fail the readiness probe. You should fail it. Okay, because once you fail it, over some time, when the readiness probe checks again, it's going to say, oh, I need to take you out of the load balancer. But up until then, you still should be serving requests. And once Kubernetes detects it that you have the readiness probe failed, it's going to take you away from the load balancer, remove you from the endpoints, and now you can go ahead and shut down for real. Okay? Now, a lot of the question is, how do you know when Kubernetes took you away from the load balancer? The short answer is that it's not a good way to know. Because the readiness probe could be running in predefined delays. So for example, it might be checking the readiness probe every 20 seconds. So after 20 seconds, then you're pretty sure, potentially after 40 seconds, you're most definitely sure your readiness probe has been checked. And then Kubernetes has done something with it. Okay? And then once you are sure, then you shut down. And this process is pretty hard to implement. There's only one thing that I found on the open source world that actually implements this really, really well in Spring Boot. And this is something from SBB in Switzerland. And I actually do like this a lot. So what you do is you basically, let me go back here. So you basically add the dependency here on the top. So I'm going to go back here to dependency. I'm going to add the graceful shutdown dependency. And then from my application, rather than using the Spring application in their stuff, you do a graceful shutdown Spring Boot application, and then you use it to run your app. Okay. Now the difference here is that they actually handle the graceful shutdown with the health checks, and they will wait for a certain period of the time, and ultimately it will then shut your application down. And this is one of the easiest way to deal with this graceful shutdown. Okay. Now, lastly, if you do have different environments that you want to deal with, so for example, what I wrote in the sample there, it's a very simple deployment that does nothing. There's no additional configuration. If you want something more complicated for QA and for staging environment, then what you want to end up using potentially is, you may have some templating system. There's Helm, there's many other things. The thing that we did adopt and also produced by Google is called Kustomize. So with Kustomize, you'll be able to create different variations of the same configuration without having to copy and paste the same configuration over and over again. So you can use that very easily to define, this is the configuration for QA. Without replicating the entire file, you can just replace a single attribute. For example, like how many replicas do I want? So in QA environment, I would just replace my deployment with replicas equal to 2, and the rest of the configuration would just be inherited. Okay, so you don't have to rewrite any of that. And that's also something that can be very, very useful. Okay, so with that all said, last thing is production is hard. One of the things I discovered is that once you have a Kubernetes cluster up and running, you run your app, and now somebody has to do all the job to secure that Kubernetes cluster. That's very difficult. Make that job easy for them or for yourself. The best thing you can do is just to make sure your container is secure, you check your vulnerabilities, and make sure you're running as a root user. That will get you really far in this whole cycle. With that being said, my time is up. So thank you so much for being here. You can find a lot more information on my other links as well. And if you have any questions, I'll be around. And thank you so much for your time. Appreciate it.